Question number 25. Find the equivalent resistance between points A and B in the network shown. Here this is point A, this is point B. We have to find out the equivalent resistance. Here network is shown. So we assume that current I enters at this point and leaves at this point. So current distribution will be, suppose this is I1 and this is I3, this is I2. So at this point, it will remain I3. At this point, it will remain I2, and this will be I1. So here, we can do one thing. We assume that the wires CD and AB don't intersect, means they are not physically connected. So we can take out this 5 ohm means 10 ohm resistor in parallel, and we can redraw the diagram. So diagram will be like this. This is 10, this is 5, this is 5, this is 10, and this 5 will make 10, and suppose that we connect as 10 in parallel. And here 2.5 will become 5. Now we have to find out equivalent resistance. The equivalent resistance of this portion, this is not balanced bridge. So this portion will come out to be 7 ohm. So we can say that 7 ohm is in parallel with 10 ohm. So we can find equivalent. So R parallel, if we evaluate, so that will come out to be 4.1. Now there is one question. Why this is 7 ohm? We have already discussed one question like this. So let's analyze it again. So here, this is 10, this is 5, this is 5, and this is 10 ohm, and there is 5 ohm resistors here. Now, suppose current I enters at this point and I1 goes through this branch, means to 10 ohm resistor, and remaining current I minus I1 passes through 5 ohm resistor. Now, due to symmetry, this will contain I1 and this will contain I minus I1. Now, to balance this resistance will contain 2I1 minus I1. This is point A, this is point B. Now we find VA minus VB. So VA minus VB will be equal to, suppose we write here C, this is D, then VA minus VC, this point is A. So this is equal to VA minus VC, and then VC minus VB, and V equal to IR. So here this is 10 ohm resistor, current is I1, plus here resistor is 5 ohm and current is I minus I1. 5 times I minus I1. So this will become 5I1 plus 5I, which is VA minus VB. Equation number 1. Similarly, we can write VA minus VB. We follow another path. Suppose we follow this path from here to C, then C to D, then D to D. So we can write it as VA minus VC plus VC minus VD plus this is D, then VD minus V. We again apply IR. So VA minus VC means 10 I1 plus VC minus VD means 5 times current is 2I1 minus I plus this contains 10I1. So if we simplify, this will become minus 5I plus 30I1. Equation number 2. This is VA minus VB, which is 5I1 plus 5I. And this is VA minus VB again, minus 5I plus 30I. Now, we have to eliminate this I1 from the equation. So for this purpose, if we multiply by 6 to this equation, so this will become 30I1 plus 30I. And then we subtract. So we can say 6 times VA minus VB means first equation multiplied by 6, then reduced by means we subtract VA minus VB, second equation directly. So this will become 30I1 plus 30I minus, this will remain same, 5I, and we are subtracting it, so it will become plus and minus 30I1. So this 30I1 will cancel out. From here, 5 times VA minus VB will be equal to, from here, this will be 35I, and VA minus VB, voltage divided by current, I will be the resistance, and that would be 35 by 5, which is 7 ohm. Hence, we have got this as 7 ohm, and then we have evaluated. Now, let's go to question number 26. It says, find the current supplied by the battery in the steady state. Steady state means capacitor will not conduct, means no current will flow through that branch where capacitor is present. So we have the circuit 2 volt, 2 ohm, and 6 ohm. So suppose current I is there. So I will be voltage 2 divided by these two resistances will be in series 8, that is 1 by 4, which is 0.25 ampere. Now further, if we find potential difference across this 6 ohm, so the same potential difference will be across the 2 microfarad capacitor. So PD across 6 ohm will be 6 times 0.25. That will be equal to 1.5 volt. Now, we have to find out the charge on the capacitor. So Q equal to CV. Capacitance is 2 microfarad, 2 into 10 power minus 6 into voltage is 1.5 volt. So this will become 3 into 10 to the power minus 6 coulomb, which is our answer. Thank you for watching.